Hello, this is Geometry Chapter 5, Relationships in Triangles, looking at segments and points in triangles, specifically 5-2 with medians. This is Mrs. Moslick. Go ahead and do the warm-up. Pause this video so you can work on the warm-up by yourself. When you're done, unpause it, go ahead and press play. Okay, so hopefully you are done and you got -5 halves comma 1, or you could write it as -2.5 comma 1. Raise your hand if you got that. Excellent. If you did not, remember midpoint formula. We are averaging our x's, so add them, divide by 2, and we are averaging our y's. So our first coordinate point is x1, y1, second x2, y2. Plug in your particular numbers. So we have 3 plus a -8 over 2, and -4 plus 6 divided by 2. So we have -5 halves, comma 2 halves, and 2 halves reduces to 1. All right, that's review from chapter 1 and from your previous math classes. Let's go ahead and do some review of your proofs from 4, 4, 4, 5. And here we're going to prove that points on a perpendicular bisector of a line segment are exactly those equidistant from the segment's endpoints. So what that means is if this is AB, is a line segment and line PM is the perpendicular bisector, this is what we have. And we want to prove that PA's length is the same as PB. So as you see, this is from 4, 4, 4, 5. That is on triangle congruence proofs. So we will have to draw in these two segments. So now we have two triangles to show. We're going to show that they are congruent to each other. And then by CP/CTC, corresponding parts of congruent triangles are congruent. Then we know that line segment PA is congruent to line segment PB. So we are going to show that the two triangles are congruent. To do that, we are going to have to use reflexive, and then we'll have a side angle side. You guys see that? All right, so review from chapter 4. In this class, when we are given perpendicular, that's 3 steps in the proof. When you see bisector of a segment, that's going to be definition of segment bisector. So let's go ahead and start the proof by the given. So line segment PM is the perpendicular bisector of line segment AB. That is the given. Now let's go ahead and do the 3 steps for perpendicular. So first of all, definition of perpendicular, use the word, is that these two angles are right angles. So measure of angle AMP equals 90, and the measure of angle BMP is 90. Hopefully you remember what the second step is. If not, let's highlight. So what I want to show is that both of these equations equal 90. Since they both equal 90, then we know that the two left pieces equal each other by transitivity. Measure of angle AMP equals measure of angle BMP, transitive or transitive property or transitivity. Remember what transitivity says is that if you have A equals B and B equals C, then our conclusion is A equals C. This is transitivity. I think of it as a train property. When you have box cars that are all connected to each other, what we have then is they all would equal each other. So if A equals B and B equals C, A and C equal B, so they have to equal each other. That's the transitive property. Okay, now we want triangle congruence, so we need to change this statement to congruent. So an angle is congruent to another angle. Measures are equal. Angles are congruent, so shapes, objects are congruent, measurements are equal. So this is definition of congruence. Okay, we are now done with the 3 steps for perpendicular. Now let's use definition of segment bisector. So definition of segment bisector would say that these two segments, AM, is congruent to BM. Now, the statements 2, 3, and 4 and the statement 5 can be in either order. Okay. Um, Also, statement 6 can be in first, like you could do 6 first, then 5, then 2, 3, 4. So these three ideas can be in any order. 6, we're going to talk about reflexive. So PM is congruent to PM by reflexive. So statement 6, reflexive is PM segment is congruent to PM. Lastly, the two triangles are congruent by side angle side. So triangle AMP is congruent to triangle BMP. And what we want to prove is that the two segments are equal in length. So PA is equal to PB. So now in red pen, I can show that. If you show what you want to prove as a tick mark, you have to use red pen, because the red in this class is representing we haven't proved it yet, but now we are. We're going to say that line segment AP and BP are congruent to each other by CPCTC. So PA is congruent to PB by CPCTC. You must write it out. Corresponding parts of congruent triangles are congruent. The corresponding parts of congruent triangles are congruent. And then by definition of congruence, the actual lengths equal each other. So definition of congruence. Hopefully you didn't feel this was awful. If you think that this proof was awful, try it a few times on your own. If you think it's a little tough, again, try it a few times on your own. If you feel like it's pretty easy, then try it one or two just to solidify it in your head. Now, if you actually want to find the balance point of a triangle, that is actually where the medians meet. So if you calculate the medians of each triangle, and again, you're approximating where right now where the midpoints are, where that point of intersection is of those medians is called the centroid. As a review from last lesson, that is the balance point of a triangle. So it's pretty fun to do that if you want to. So a median is where you're going from a vertex to the opposite midpoint, and where all of the medians meet is called the centroid. So median is each line segment, centroid is the point where they all intersect. So for instance, on this picture, let's just approximate where that median is and where this median is, midpoint. And so this would be the actual centroid. Centroid is really interesting. Not only is it just defined as the point where three medians of a triangle intersect, it's the balance point or the center of gravity of the triangle, which we just talked about. Also, each median cuts a triangle into two regions with equal areas. The three medians form 6 triangles with all equal areas, and the centroid on each median cuts the medians into a ratio of 2 to 1. Very fun stuff for mathematicians. You just need to know that the centroid is the balance point or the center of gravity, or in other words, is the middle of your triangle. So when you want to find the centroid coordinate point, you are averaging the x values and you're averaging the y values. And again, that helps us to understand why that is the balance point or the center of gravity. So example 1, we want to find the centroid. So we have the centroid is, I'm going to take the average of all of my x's. So we have my first point, my second point, and my third point. So the centroid is, we already have the formula there. So normally you would have to write it down, but since it's right there, we're not going to waste our time with that. And I am going to average the x's and average the y's. So add up all of the x values, you get 9 and divided by 3, and add up all of the y values, you get 18. So our final answer is 3, 6. You won't always have integer coordinate points. In this example, we do. Okay, now we're going to review factoring. You may or may not remember it from algebra, so let's review the steps. Number 1, put the expression in standard form, meaning exponents, biggest exponents first going all the way down. It is in standard form. Second step is factor out a greatest common factor. We can take out a 5. So I will distribute out a 5, factor out a 5, and we're left with x squared plus x minus 2. Next step, because this is a trinomial in parentheses and the leading coefficient is 1, I'm looking for two numbers that multiply to get -2 and add to get the coefficient of the x, which is 1. So let's go ahead and write out those factors of -2. So two numbers that multiply to get -2, -1 and 2, or 1 and -2. Which one of those adds to get the 1? That would be -1 and 2. So go ahead and circle the -1 and 2. As you're doing that, go ahead and factor completely. In this class, we want to make sure you are ready for Algebra 2. It will be required for every problem that you factor, you must check your work. So geometry, whether you're in geometry, geometry accelerated, or geometry honors, it is important and necessary that you check your factoring. So let's go ahead and then check your factoring. Right now, we're just working on waiting for Word, but you guys can be working on that right now. So we have now our complete factorization, which is 5. And then we have our double bubble, which is our x, and then the two numbers that add to get the positive 1 was the -1 and 2. So this is our complete factorization. As I said before, you must check your work. So write out the word check, rewrite the factored expression, and then you can only multiply two items at a time. So let's go ahead and multiply the two factors, keeping the 5 out in front. So we have an x times x is x squared plus 2x minus 1x minus 2, and then add like terms. So we have 5 times the quantity x squared plus 1x minus 2. And that is what we had here. So that's a good check. And then finally distribute the 5. So we have 5x squared plus 5x minus 10. And that is what we started with originally. So we did a good job. Now, with example 3, we're going to factor completely. The first step is it in standard form? Yes, it is. Second step, can you factor out a greatest common factor? You cannot. So our third step now is to look at the leading coefficient. It is not 1. So in this case, we're not going to do the double bubble as we did before. We're going to do crisscross split the middle term. So we're looking for two numbers that multiply to get the product of the first and last terms and add to get the middle term. So the product of the first and last is -6x squared, and the middle term is a positive 5x squared, 5x. So now we're looking for two numbers that multiply to get -6, add to get 5. So multiply to get -6 would be -6 and 1, 6 and -1, -3 and 2, 3 and -2. So which of those pairs add to get 5? That's the 6 and -1. So we have 6x and -1x, or you can put the -1x first, does not matter. And now we're going to rewrite this. This is called crisscross split the middle term way of factoring. It is not the only way to factor, but this is where most of our students will be doing it this way, crisscross split the middle term. So we rewrite our expression. This is our 3x squared plus 5x minus 2. Now, we've just done the crisscross. We're going to now split the middle term. We're going to replace what's in the rectangle with these two items in this new rectangle. So 3x squared plus 6x minus 1x minus 2. So we're just replacing 5x with 6x minus 1x. Now we're ready to factor the first two terms and factor the next two terms. So take out a greatest common factor. That would be a 3x. We're left with x plus 2. Factor a greatest common factor and make sure you have your leading coefficient in each factor positive. So we're going to take out a -1 and we're left with an x plus 2. So if you distributed that, you would get that -1x minus 2. And now we have two terms, and both terms have a common factor of x plus 2. So we are ready to now factor out that greatest common factor, which is x plus 2. So we have an x plus 2, and then what's left is this 3x minus 1. That is our answer. Because we're in geometry, we are going to check our work. So we're going to rewrite x plus 2 times the quantity 3x minus 1, distribute, and we have a 3x squared minus 1x plus 6x minus 2. Adding like terms, 3x squared plus 5x minus 2, and that is what we started with originally. So we did it well. Hopefully you enjoyed this centroid formula and a little review of factoring from algebra. You will eventually have a factoring quiz or test this year, so just make sure that you are being diligent with remembering factoring. If you don't remember factoring, get extra help as you're working the practice problems. Have a great day. Hope you guys ask questions if you have any questions. Thanks and have a good